Okay, so we're going to go more in depth with trig this time, more in depth with SOHCAHTOA. So if we're missing an angle this time, we're not just setting up our proportions of our sides to find a missing side. Okay, so thinking back, if we're coming from angle A, remember opposite sits across from, this is always my hypotenuse, it sits across from my right angle, and adjacent sits next to. So when we do these, sine, remember if we wrote out SOHCAHTOA, sine is your opposite over hypotenuse, so the thing that sits across from it over your hypotenuse. Cosine is your adjacent, so the thing that sits, the side that sits next to it over your hypotenuse. And tangent is the opposite leg over the adjacent leg. Okay, so here's our SOHCAHTOA with sine, cosine, and tangent. So we're going to do one of them. This one's coming from angle X, so we're going to label this is my hypotenuse. This is the thing that's adjacent, and this is opposite because it sits across from it. So if I write out SOHCAHTOA here, okay, sine is opposite, so 8 over my hypotenuse, 16, which simplifies to 1/2. Cosine is adjacent, so 8 square root 3 over hypotenuse, 16. So I would type in 8 square root 3. You have to press the over button in your calculator, divided by 16. That simplifies to square root of 3 over 2. And then tangent is going to be opposite over adjacent. So I type in 8 divided by 8 square root of 3, and I get square root of 3 is my simplified answer. Okay, so this one is coming from X. So this is my hypotenuse. This is the thing that's opposite, and this is the side that's adjacent. So if I write SOHCAHTOA up here, sine is opposite over hypotenuse, so 4 square root 5 over my hypotenuse is 12. So 4 square root 5, press the over button, divided by 12, I get square root of 5 over 3. Cosine is adjacent over my hypotenuse, so 8 over 12 simplified is 2/3. Tangent is opposite, so 4 square root 5 over adjacent, so 8. So that simplifies to square root of 5 over 2. Okay, trigonometric ratios. Because of similar triangles, trigonometric ratios are the same as long as the angle measure is the same. We can use calculators or a chart to find the ratio for a certain angle, then solve the ratio. So we can use trig to find certain angle measures if we are given 2 side lengths. Okay, so you're going to make sure your calculator mode is in classic. Okay, and then you want to make sure your float is sitting at 4. Okay, so when I do these, I'm going to type in the sine button and then 13, and it gives me 0.2250. The reason we picked the 4 is so that we can do 4 decimal places. Then I type in cosine of 84, I press enter, that gets me 0.1045. I can press tangent and press in 27 to get 0.5095. Okay. When we're trying to find an angle measure that's missing, we have to use something that's called kind of like the inverse. So if I'm trying to cancel this sign to get this x away, to get the x by itself, we need to do this thing called arc cosine or inverse sine. Okay, they mean the same thing. So this is inverse sine. So they will cancel each other. X equals, I need to type in inverse sine, so I have to press second sine to get the sign to the -1, 0.0175. Okay, so once I type that in, I should get 1.0027, and that's the degree of the angle that's missing in this. Okay, so now if I type cosine, this time I need to take the inverse cosine. So they cancel on this side. I got x by itself. I type in second cosine to get the cosine to the -1, 0.2756, and I get x is equal to 74.0022 degrees this time. Okay, my next one, we have to do inverse tangent so that cancels. X equals, I type in second tangent, 4.0123, and I get 76.0051 degrees. So this is whenever you're missing an angle, because we normally put our angles in here. Now the representative of x. Okay, so in my first example, we're trying to find a missing side. So normally we could use Pythagorean theorem. The problem is I only have one length. So this is when we have to use trig to be able to find the other length as long as I'm giving an angle. So if I'm coming from the given angle, 34, this is going to be my hypotenuse. This is opposite, and here is adjacent. Okay, so 8 is my hypotenuse. X is my adjacent. Okay, so when I'm typing it in, out of my SOHCAHTOA, I want the one that has to do with hypotenuse and adjacent. So we're going to be using cosine. Okay, remember, the thing that goes next to the cosine, sine, or tangent is always the degree. This time I'm giving you the degree of 34. Okay, cosine represents adjacent over hypotenuse, so the adjacent is x, and my hypotenuse is 8. Okay, so when I am solving it, I want to multiply both sides by 8 because I need x by itself. So I got this is equal to x. I got 8 cosine of 34 degrees. So all I'm going to type in my calculator is this, 8 times cosine of 34. 8 cosine. Okay, and then I'm going to get x is equal to 6.6323. Okay, that is my side length that I am missing. So whenever you're given the degrees, you might have to set up your proportion and then plug the degree in next to the sine, cosine, or tangent. So here is the angle that I'm coming from because that's what's given. This is my hypotenuse. This is my opposite. This is my adjacent. So the two things that I have information on are my hypotenuse and my opposite. So out of my SOHCAHTOA, which one includes opposite and hypotenuse? Sine does. So when I'm writing this out, I got sine of my degrees, 29. Well, sine represents opposite over my hypotenuse. Okay, my end game is to get x by itself, so we're going to multiply both sides by 13. And that is what I'm going to type in my calculator. So 13 times the sine of 29, I got my side length to be 6.3025. Okay, so this time, coming from this angle here, here's my hypotenuse, here's my adjacent. So out of my SOHCAHTOA, which one includes adjacent and hypotenuse? Cosine does. So when I'm doing this, I do cosine of my given angle measure, 44, is equal to my adjacent over my hypotenuse. So this time we're multiplying both sides by 22. So I got t is equal to, I type in my calculator, 22 cosine of 44, and I get 15.83, or 15.8. Okay, so my next one, I'm coming from this angle, so I have my opposite, and then I also have my adjacent. So the one that deals with opposite and adjacent is tangent. So I have tangent of 46 equals my opposite over my adjacent. So this time I need to multiply both sides by 10.5. So I type in 10.5 tangent of 46. 10.5 tangent of 46, and I get 10.87. Okay, this one we're coming from 20. We are trying to find the lengths of each right triangle. So let's go ahead and find this one first. So if I labeled, this is my opposite and my hypotenuse. So SOHCAHTOA. So the one that includes opposite and hypotenuse is sine. So I got sine of 20 equals my opposite over my hypotenuse. So I'm typing in my calculator 8 sine of 20 because I need to multiply both sides by 8. So 8 sine of 20. So that side length is 2.7. Okay, and now let's say this side represents y. We're still coming from the same angle, so this is my hypotenuse and my adjacent. So the one that includes adjacent and hypotenuse is cosine, so this one is cosine of 20 equals my adjacent over my hypotenuse. So in my calculator, I'm typing 8 cosine of 20 because I need to multiply both sides by 20. So 8 cosine of 20, that side length is 7.5. My next one, we're coming from 60 here. You can notice that it is a 30, 60, 90 triangle. So technically, if you wanted to fill it out that way, you can. Otherwise, what you could do is represent, let's say this is x, and we're going to do it the same way. So I have my opposite and my adjacent. So opposite and adjacent is tangent, so I got tangent of 60 equals my opposite over my adjacent. So I need to multiply both sides by 5, so 5 tangent of 60 is going to equal that x there. So 5 tangent of 60. So that side length is 8.6 or 8.7 if we rounded. Now if I'm trying to find, let's say this is y. Okay, so when we're looking at y, this time we need the hypotenuse and adjacent. So the one that's talking about the adjacent and hypotenuse is cosine. So we're doing cosine of 60 equals my adjacent, so 5 over my hypotenuse y. This one's a little different because if we're trying to solve for y, let's go ahead and multiply y to both sides. So I got y cosine 60 equals 5. Y is not by itself, so I need to divide by cosine of 60 to move them over. So this time in your calculator, you're typing in 5 divided by cosine of 60. Okay, that side length represents 10. So be careful of how you're solving for these variables. Okay, my next one, let's say we're finding this. So we're talking about angle 50, so this represents opposite and adjacent. So the one that talks about opposite and adjacent is tangent. So tangent of 50 equals opposite over adjacent. So this one's similar. Multiply both sides by x. Divide by tangent of 50 to get x by itself. So I got x is equal to 10 divided by tangent of 50. So 8.4. Okay, now I'm going to erase this so that I can do this hypotenuse since I took up some space. Okay, so now we're still coming from angle 50, but we're trying to find this. So we're talking about the opposite and the hypotenuse. So the one that talks about opposite and hypotenuse is sine. So I got sine of 50 equals the opposite over the hypotenuse. So we multiply both sides by y. We're going to divide by sine of 50. So we're going to take in 10 divided by sine of 50. 10 divided by sine of 50. And that side length is 13.1. Okay, this one, we're coming from this. I have my opposite and my adjacent. So in my SOHCAHTOA, that's tangent. This time I don't have the angle. Let's change colors here. So I'm going to put tangent of what represents my angle, so x. So we're going to do our opposite over our adjacent. Okay, so remember, if we're trying to find the angle, I need to get x by itself. So I need to do the inverse tangent of both sides to get that x by itself. So when I type it in, I type in second tangent to get the inverse tangent, 12 divided by 15. So my angle measure then is 38.7 degrees. Okay, my next one, we're missing a side, so we're coming from this 32 here. So I have my hypotenuse and my adjacent. Okay, out of my SOHCAHTOA, we're doing sine. So I have sine of my angle measure equals, it is cosine because it's adjacent. Cosine of 32 equals my adjacent over my hypotenuse. Multiply both sides by 24. So we type in 24 cosine of 32. So my x is equal to 20.35. Whoop. Okay, my last one, we're finding the angle again. Okay, so I got my hypotenuse and my opposite. Okay, so we're going to be talking about sine because we have opposite over hypotenuse. So I have sine of my angle measure, which is x, represents my opposite over my hypotenuse. So to get rid of sine, you have to do the inverse sine to get x by itself. So I type in second sine, so I get my inverse sine, 13 divided by 17. So my angle measure is 49.9 degrees.